Welcome to This Explainer. Okay, I want you to imagine for just a second that you're a world-class chef. You're working in a state-of-the-art kitchen using the absolute best culinary techniques known to humanity. But if the ingredients you toss into your pan are rotten, well, it doesn't matter how great of a chef you are, that meal is going to be terrible. Research operates on the exact same principle. Today, we're talking about sampling and survey design. In the world of quantitative and qualitative studies, your initial sample, the actual people you get your data from, is your raw ingredient. If you use bad sampling, you will entirely ruin even the most mathematically sophisticated, well-designed study out there. You simply cannot fix bad ingredients once they're already in the pot.
All right, let's dive right into this roadmap. 1. Why sampling matters. 2. Choosing a sample. 3. Crafting your survey. 4. Piloting and administration. And 5. Avoiding those common pitfalls.
So, Section 1. Why sampling matters, and really the high stakes of selection. As researchers Gay, Mills, and Erijan so perfectly put it, a poorly chosen sample can undermine even a well-designed study, and literally no amount of sophisticated statistical analysis can fix a fundamentally flawed sample. I really want to emphasize this right out of the gate to establish our core problem. Statistical cooking techniques cannot save rotten data ingredients. Look, very few studies have the time or resources to examine an entire population, so researchers select a subset, a sample, to represent the larger group. But if that sample is biased or unrepresentative, your conclusions are entirely distorted. This means the sampling decisions you make very early in a study's design are disproportionately important compared to the amount of attention they sometimes actually receive.
To really grasp this, we've got to clarify the critical difference between sampling error and sampling bias. These two might sound similar, but they are wildly different in terms of the threat they pose to your research. Sampling error is totally natural. It's the unavoidable, mathematically expected variation between a sample statistic and the true population. It's not a mistake, and the good news is that it naturally shrinks as your sample size increases. Sampling bias, on the other hand, is a study-destroying systematic distortion. This happens when certain members of the population are systematically more or less likely to be included than others. For example, if you're conducting a survey on student workload, but you only end up surveying the highly motivated, organized students who happen to eagerly volunteer, yeah, your results are heavily biased. And unlike sampling error, you can't fix sampling bias just by tossing more people at it. A massive bias sample is still mathematically flawed.
Moving on to Section 2, choosing a sample or finding the exact right people.
So when you're choosing your sample, you're generally looking at two totally distinct approaches: probability sampling and non-probability sampling. In probability sampling, every single member of the population has a known non-zero chance of being selected. This is usually driven by random chance, and honestly, it's your absolute primary safeguard against bias in quantitative studies. Because it's randomized, it allows you to statistically justify generalizing your findings back to the whole population. Non-probability sampling, however, relies on participants who are selected based on availability, referrals, or just the researcher's judgment. While this is incredibly common in qualitative or exploratory research and perfectly valid for those specific aims, it strictly limits your ability to generalize your statistics to the broader population.
And there are quite a few specific methods you might use under those two umbrellas. You've got simple random sampling, like literally drawing names from a hat, systematic, where you pick every 10th person, and cluster sampling, where you randomly pick entire classrooms at once. But let's look closer at stratified random sampling, because this brilliantly illustrates how deliberate you have to be. Imagine a researcher doing a study on English as a foreign language, or EFL students. To ensure they don't accidentally just get a bunch of advanced students purely by random chance, they divide the population into strata: beginner, intermediate, and advanced. Then they randomly sample an equal number, say 60 students, from within each of those specific subgroups. That is stratified random sampling in action. It guarantees representation across all critical levels of the population. Conversely, if our researcher just surveyed the students sitting in their own classroom because it was, easy, that would be convenience sampling, a non-probability method that completely prevents them from claiming their results represent all EFL learners.
So, right about now, you're probably wondering, how many people do I actually need? Well, while larger samples naturally reduce sampling error and increase your statistical power, a highly practical rule of thumb that methodologists often suggest is 20 to 30 participants per group for a simple two-group comparison. This maintains reasonable statistical power without completely draining all your resources. However, you've got to keep in mind this is a rough minimum. Your true requirements are going to depend heavily on the expected effect size and the specific type of study you're actually running.
Okay, Section 3, crafting a survey, which is really about designing your instrument.
You can think of bad survey questions as these hidden traps that subtly distort your data without you even noticing. To avoid these traps, you absolutely must follow the core principles of good question wording. You have to keep the language clear and appropriate to the respondent's proficiency level, which is especially critical in applied linguistics. You've got to avoid leading or loaded wording that quietly biases responses toward whatever it is the researcher wants to hear. You should avoid double negatives like, do you disagree that grammar is not important? Which, let's be real, just confuse people. Your multiple choice options must be mutually exclusive and exhaustive, meaning every single respondent finds exactly one option that perfectly fits their situation with zero overlaps. And finally, you have to sequence the questions logically, moving from general, easy items into the more specific or sensitive ones.
Let's zoom in on one specific trap that is honestly incredibly common: the double-barreled question. Have you ever been trapped by a survey asking you two things at once? Like, imagine a question that asks, do you find grammar and vocabulary difficult? If a student answers yes, what exactly are they saying yes to? Do they struggle with grammar or vocabulary or both? And if they answer no, does that mean they find both easy or just one of them? It literally makes it impossible for you as the researcher to know which part the respondent is actually answering. It completely destroys the reliability of your data for that item. Now, there's actually this fascinating debate in the research world over Likert scales. You know, those rating scales where you select strongly disagree all the way to strongly agree. You have to make a very deliberate choice between using an odd-numbered scale or an even-numbered scale. An odd-numbered scale, like a 5-point scale, includes a neutral midpoint. This allows genuinely undecided respondents to give an honest, neutral answer. An even-numbered scale, like a 4-point scale, completely removes that midpoint. It forces respondents to lean at least slightly toward agreement or disagreement, basically preventing them from fence-sitting. Neither choice is universally correct, but the choice has to be deliberate. In our previous EFL student example, the researcher used a 5-point scale specifically because they wanted to allow for genuinely uncertain responses regarding language learning strategy use. Whatever you choose, it has to match your specific research goals.
Section 4, already, piloting and administration, testing and deployment. Let's see how all this builds into a reliable procedure. You draft your items based on existing literature, and you group them together logically. But step 3 is where the magic happens. You pilot the survey with a small group that is very similar to your target sample. Returning to our EFL worked example, the researcher didn't just blast their survey out to the whole university. No way. They piloted it first with just 15 students. And thank goodness they did, because those 15 students pointed out two confusing, double-barreled items. The researcher revised them based on that feedback before full distribution. Problems caught at this pilot stage are incredibly cheap and easy to fix. Problems caught after hundreds of responses are already submitted, well, those can completely ruin your final data set.
So the really crucial point here is what happens when you finally push send and distribute the survey. Let's say you invite 400 students to participate and 260 actually completed. That gives you a 65% response rate. That sounds pretty good, right? But look at the remaining 35%, the 140 non-responders. A low response rate isn't just annoying because it lowers your sample size, it introduces a terrifying threat called non-response bias. The students who chose not to respond might systematically differ from those who did. If you're sending out a survey measuring student motivation, who is the absolute least likely to fill it out? Unmotivated students. If that happens, your results will artificially look incredibly highly motivated, totally distorting reality. And this is exactly why you absolutely must report your response rate transparently. Finally, Section 5, avoiding common pitfalls and dodging those survey traps.
We've touched on several of these, but let's run through them really quick. Trap 1, convenient sampling disguised as generalizable data. You just cannot survey only your own classroom and claim the results represent all learners everywhere. Trap 2, skipping the pilot. We just saw how an unpiloted survey permanently locks in ambiguous wording. Trap 3, overly long surveys. Something as simple as a 60-item questionnaire causes severe respondent fatigue. They get tired, they stop caring, and they just start clicking C all the way down the page. That ruins data quality even among willing participants. Trap 4, ignoring low response rates and the non-response bias we just discussed. And finally, treating a 5-point Likert scale automatically as interval data without any mathematical justification, which can lead you to use the completely wrong statistical tests on your data.
Ultimately, sound sampling and careful survey design are the absolute foundation of valid, trustworthy research. You have to decide everything in advance, very deliberately, from probability methods to scale formats, rather than just reacting once data collection is already underway.
I want to leave you with a final thought to help you ponder the true validity of the very next survey you encounter in the news, at work, or just out in the real world. When you see those results, ask yourself, are they actually measuring the population, or are they just measuring the people who had the time to answer? Thanks so much for joining me on This Explainer, and I'll see you next time.